The vCare ontology defines a schema for vCare relevant data, processes, and reasoning approaches. Besides novel concepts and relations, the vCare ontology also reuses and links to available schemas such as Universal, IoT Lite, Kinect, Semantic Sensor Network, or REDLEX. The patient profile is a central part of the ontology, consisting of heterogeneous information relevant for treating the patient, which are recorded in the respective hospitals. It links to a rich model for diseases describing symptoms as well as possible treatments. A patient is situated in an adaptive clinical pathway which models the planned activities for individual days. Here, possible activities are conceptualized and gathered such that there is a unique definition of available activities for individual steps of the pathway, as well as relevant parameters to personalize the respective activities. The pathway representation is linked to a decision-theoretic model which integrates all relevant information required for the reasoner to recommend activities and pathway adaptations. The decision-related concepts comprise state and observation features and require condition rules to set up a decision-theoretic model. A state encapsulates all relevant information at a single point in time in order to adapt the clinical pathway with respect to a novel activity. The observation feature models the transformation of the state to actual values a statistical model can utilize. The condition rules model the feedback for the decision-theoretic model, which is used to adapt and personalize the recommended activities. We model the problem of recommending activities which are beneficial for a patient's rehabilitation as a Markov decision process, which directly targets the challenge of gradually exploring which activities are performed and adopted the best in order to maximize the sustainable improvement of a patient's health for a longer period of time. The observation features of occurring states are fed into the Markov decision process in order to retrieve a distribution of available activities which quantifies their current expectational benefit. The condition rules, as well as manual feedback mechanisms for the patient, for example a Borg assessment, are used to calculate a numerical reward which is used to update the Markov decision process over time. In the previous scenes, we have seen the concept of vCare applied to the case of Mr. George. But how is the system working in the background? Let's briefly remember the architecture. The diagram shows the basic functionalities provided by the different work packages in the project. The left side represents the services and the interaction devices deployed at the home of the patient, and the right side represents the services run by the vCare cloud infrastructure. The communication between all these services is handled through the middleware. When the doctor prescribes a new care pathway, it uses the professional portal. Through this portal, the doctor can select from a set of pathway templates defined in the Pathway Template Manager. The template is a generic care pathway that must be personalized to the specific patient. The doctor fills in some parameters to define physical rehabilitation activities based on the list of services available. In more detail, it will be using a physical training service which needs information about which exercises are available, the number of sessions per week, the duration of each session, and the intensity, measured as the heart rate interval to aim during the session. The personalized template represents the rehabilitation treatment for the patient. Once the treatment is activated, it will configure additional services, for example the scheduler, which the avatar will use to suggest the patient when to start a training session. The vCare system at Mr. George's home receives the configuration of the new treatment prescribed. When the time to start the first training session comes, the smart home will detect when Mr. George is at home and close to the avatar. This information is sent to the avatar, which will recommend the user to begin the exercise. When Mr. George confirms that he is ready, the avatar triggers the physical training service, which interacts with Mr. George through the virtual coach. The first step is to ask Mr. George to switch on his activity tracker that will send vital signs to the physical training service. When Mr. George exercises below the prescribed intensity, the avatar will encourage him to train harder. On the contrary, when Mr. George trains too hard, the avatar will encourage him to slow down or even stop the session. When the session finishes, the avatar will trigger the user feeling service, which gets a feedback from Mr. George through a questionnaire. For example, Mr. George will have to answer the perceived effort with a Borg scale. The performance information recorded by the physical training service and the perceived effort gathered through the user feeling service are sent after the session to the decision master, which will run the corresponding agents to perform the adaptation of the care pathway and give further feedback to Mr. George in the form of educational contents.